Well, I guess we're live. Not really sure how this is gonna go. This is kind of a spur of the moment thing, but hopefully it goes well. Um, if you're watching, feel free to talk in the chat. That's really how I'm gonna get all of our feedback here, so I know what questions to go over, or else I'm kind of just gonna go in order. Well, I guess we can get started. Hopefully, you guys have your test on hand, and that way. Oh wait, I should probably actually pull it up, shouldn't I? Here we go. Does this look familiar? Okay, so I'm looking at the chat on my phone, and I know there's a little bit of latency here. I think there's around like 10 or so seconds, and so I won't move on way too quickly, but if you have a question, don't hesitate. So just so this can go as smoothly as possible. Okay, well, let's get started, I guess. Ooh, wait, I don't have the draw option on here. That's a little annoying. Um, okay, here's what I'll do. Go like this. This is a good idea. I'm really doing this on the fly here, so just bear with me. Okay, I really have no idea of like the skill level in this room, so unless you guys give me some feedback, I'm kind of just gonna start going. I think that's the best way to do this. So, well, I guess we can just start at the beginning. By the way, this is gonna last around an hour, and we're just gonna see how far we can get in an hour. So, I guess we can start with the first one. Um, well, this is just, let's see, this is just multiplying by one digit number. You could make it a little bit easier and like split up this 2023 into like 2000 and then 23 and then do a little bit of distributive property. So 2000 times 4 is 8000 and then 4 times 23 is 92. So you get an answer of 8092. XP does events. I see you. What school are you from? I guess it's going to take you a little bit to hear that actually. So I'll just keep going. Let's see. Next we have 1/2 divided by 5/8. So this is just your basic dividing fractions, right? So whenever you're dividing by a fraction, you just take it and then multiply by the reciprocal. So instead of dividing by 5/8, now we're going to multiply by 8/5. So simplifying this a little bit, 8 divided by 2 will cancel to 4, and so you end up with just 4/5. Siddharth, nice to see you here. Not entirely sure how to say your last name, and I'm a little bit afraid to butcher it, so I'm not gonna attempt that right now. Later on, if I can figure it out, hopefully we can set up like a voice call, like Mr. Cantu does, but I'm not 100% sure how to do that yet. Crosby High School, okay. Haven't heard of that, but then again, I live in West Texas where there's like half the schools, and so obviously I haven't heard of a lot of them. Well, I'm sure with you on the team, we're gonna be hearing that school a lot more, right? I guess that's why you're here. Okay, let's move on. Number 3, 236 minus 632. So you could just subtract this, but there is a little bit of a trick here where you're subtracting reverses. So see, these two numbers just are the same, but just backwards. And when you see this, well, first of all, you're going to have to switch them at first because you're going to get a negative number. So you see this 632 minus 236. Well, first you just find the ones place. Well, that's pretty straightforward. You can't do 2 minus 6, so you carry to get 12 minus 6, which is 6. And then the middle number is always 9. And then the hundreds place is always just 9 minus your ones place. So that's your hundreds place. And so since it's negative, we just add this negative sign out front. If you're just joining us, I'm I'm kind of just working in order until I get some suggestions. Hopefully you guys have your test in front of you, but yeah, we're kind of just going to work in order until we get some suggestions. So feel free. All right, number 4, 202.3 plus 0.02. So in this case, I'll probably do the decimal parts first, right? 0.3 plus 0.02 is going to give 0.32. And then 202 plus 32 gives 234. Pretty straightforward. 31 squared, just have that memorized. You should probably memorize your squares at least to 40. And then there's some tricks you can use for like 41 through 50 and then 50 through 60. There's some tricks there. But at least memorize your squares to 40. That'll help you a lot. Let's see, 85% as a fraction. Let's see, how can we do this? Well, 85% is the same thing as just 85 over 100, right? So I guess all we have to do is just simplify this fraction. So these are both divisible by 5, so 17 over 20. Pretty straightforward. Number 7, 25 times 16. So this is a trick for multiplying by 25. Pretty much what you do is just 25 is a fourth of 100. And so we can take the 25, multiply it by 4, take the 16, divide it by 4, and then you should have something that's equivalent. So if I multiply the 25 by 4, you get 100. Divide the 16 by 4, you get 4. And so you just get 400. I guess the short way of saying that is just 16 divided by 4 multiplied by 100, or even simpler, just add 2 zeros. Okay, let's see. Number 8, a little bit of scientific, or not really scientific notation, but this times 10 squared really just multiplies it by 100. It says 13 and 14 squares. 13 and 14 squared are palindromes of 31 and 41. Oh, I guess they are. Wait. They're palindromes. 13 squared is 169. Oh, 13 and 12. Oh, I guess you're right. That's interesting. I'm reading it for anyone that's confused right now. I'm just reading the chat. 12 squared equals 144. 13 squared is 169. Yeah, 961. That's pretty interesting. Not sure why you brought that up. Does that come up later on the test? I mean, it's cool. Like, you don't really need a reason. Anyway. All right, we're just going to move on then. All right, so number 8, this times 10 squared is just going to move the decimal over 2 to the right. And so in the end, this is just 2023 plus 1, which is 2024. Brent Ashley says, how do we not miss 15 problems on this test? It is a struggle, dude. I'm not even going to lie. It is a struggle. Last year at state, I finished the whole test, and I was feeling really confident, and then I missed 12 problems. So my answer is, when I find out, I'll let you know. I will let you know. Okay. That's a good question, though. I've been trying to figure that out since I was a freshman. All right. Number 9. You can really just do this in order. 714 divided by 7 is just 102. Divided by 2 is 51. And then finally we get to an estimation. Well, you have 309 times 311, and when you multiply those, this 31 is going to be pretty insignificant, so just ignore that. Okay, so it says, it's a cool way to recall for those who don't have those upper squares Oh, I see. Yeah, okay, I guess you could do that. Okay, that's true. So if you have 12 squared memorized as 144, then the inverse of that is also the inverse of 144. Yeah. I mean, personally, I would just memorize squares, but that's pretty cool. That's good for if you're on the fly and you just blank on your squares. Okay. Well, anyway, you can kind of ignore this 31 because it's so small compared to these numbers that are being multiplied. And so what I would do is round both of these to 310. And then 31 times 31, we saw up here, is 961. And then you just got these 2 zeros extra. Okay, well, if you're just joining, we're just going over this test. I'm kind of just going in order. But if you have any questions, feel free to ask, and I'm more than welcome. I'm more than happy to jump around. Uh, this is kind of a spur of the moment thing, so I don't really have any particular plan. I was planning to go until around 6:30 unless we finish early. But yeah, I guess we're done with that. Well, let's move on to 11 through 20. If you don't have the test, I guess I could just show it right here. And maybe this will refresh your memory. If there's anything in particular that you want. Can I do 81? You know what? I wish I could. I haven't unlocked that part of the test yet. Okay, not seeing anything yet, but I'm gonna keep going, but then if someone asks, I'm gonna just pop back over there. I have a feeling you guys are gonna want a lot of the back page. But then again, I don't know if that's if that's part of the test that you get to, so trying to just make this as helpful for you as I can. Alright, let's look at this. Alright, we got 75 times 75 for number 11. There is a pattern that this follows. Um, and it seems like you would use 75's trick if you've heard of that, but there's actually a better way of doing this. So anyway, whenever you have whenever you have two numbers multiplied together that follow a pattern like this. So here's an example, like 34 times 36. The tens places are the same, and the fours, and not the fours, the the ones places they add to 10, right? When you do that, when you have that pattern, then you can use this formula. So you just take the ones places and you multiply them together. So 4 times 6 is 24. And then you look at the tens digits, you increase one of them by 1, right? So now instead of having 3 and 3, we have 3 and 4, 3 and 4, which multiplied together gives you 12. And because of the way you like bump up one of these by 1, we call this the bump it trick, or at least that's what I was taught. Okay, so you can see it's a little bit different because like our ones places are the same, but you can see that for 75 times 75, this trick actually applies, right? Our tens digits are the same, and then our fives, not our, I keep doing that. And then our ones places, they add to 10, right? 5 plus 5 is 10. So to get this answer, 5 times 5 is 25, and then 7 times 1 more than 7, 7 times 8 is 56. Nice, okay, let's just keep going. I'm not seeing any suggestions yet, so I'm just going to keep rolling. Okay, 3 to the 0th. This is just an order of operations thing, right? So you do multiplication first. 3 times 3 is 9. 3 to the 0th is just 1. So 1 plus 9 is 10. And then minus 3 is 7. Okay, pretty straightforward. Okay, number 13. You may have seen problems like this before. This is pretty common. You might have even seen this in just in your regular class, in your regular math class. But what you can do is like multiply diagonals. And then whichever diagonal gives you the larger number is whichever fraction is larger. And this just comes from like common denominator stuff. But so like if I start down here and do 13 times 3, that gives me 39. If I go from here to here, 14 times 4 gives 56. Well, 56 is larger, so I know 4/13 is going to be larger. Okay, and then we have 12 square feet is how many square inches? Well, there's 12 inches in a foot, so there's going to be 12 square inches in a square foot. And if there's 12 of them, then this is just going to be 12 times 12 squared, which is 12 cubed. And this is probably one you should have memorized as well. Cubes from 1 to 20 are pretty good to memorize, just as a rule of thumb. Yeah, so 12 cubed you would have memorized is 1728. Okay, I don't see any more messages, so we're just gonna keep going. Okay. I'm gonna erase some of this stuff at the top just so I have more space to work with. Okay, checking the chat real quick. Okay, it looks like we're good. Okay, 15. So you can see this is just a sequence where like the next term is always going to be one more, and we call this the kind of numbers that fit this kind of sequence are called triangular numbers, right? Like the first triangular number is just 1. The second triangular number is 1 plus 2. The third triangular number is 1 plus 2 plus 3. And you can see right here, since we end in 39, this is going to be the 39th triangular number. So when calculating these, you use this, it's a pretty simple formula. So the sum is equal to n, this is for the nth triangular number, right? So in this case, n would be 39. So n times n plus 1 divided by 2. So this is going to be 39 times 40 divided by 2. And very frequently you can make like a simplification. Like here, instead of doing 39 times 40, I could do 40 divided by 2 is 20. And then that simplifies this to 39 times 20, which is just 780. Okay, so pretty straightforward. You just need to know this formula, and then you're pretty much set. Okay, so I'm seeing how often do you do these streams? Well, this is actually the inaugural Number Sense stream. So this is everyone here that's seeing this is like the birth of the Number Sense streams. I kind of just got home from school today and was like, it'd be cool if I did this because I'm kind of stuck here because there's a storm going on. But yeah, this is the first one. I'll try to have them like every week maybe. I'll definitely do one once UILB gets released. But I might do some for like TMSCA if you guys will send me those tests like on the Discord. But yeah, this is the first one. All right. Yes, Cookie Master, there are only 80 problems. Thank you. Okay. Number 16, 202 plus 317 divided by 4. Okay, I'm going to erase some stuff down here. You guys enjoying this so far? For the new people joining us, if you have any questions, feel free to ask. I'm kind of just working in order until someone asks me something specific. But if you're getting good stuff out of this, then I'm just going to keep going. It says, how do you do problems like 15 but increasing by a number other than 1? Okay, that's actually a really good question. Okay, so let's do an example. So say instead of increasing by 1, we're increasing by 3. So maybe I have 2 plus 5 plus 8 to, let's say, to 41. Okay, so this is what's called an arithmetic sequence, right? And technically this is also an arithmetic sequence, and the only condition is that you're always increasing by the same number every time. So like here you're always increasing by 1, here you're always increasing by 3. Okay, so yeah. So the formula for this, it's similar, and you can simplify it to get this formula. But anyway, the formula is n, where n is the number of terms, times the first term plus the last term, and then divided by 2. So the tricky part here is actually finding the number of terms. So to find that, the number of terms is just the last term minus the first term divided by the common ratio and then plus 1. And I'll show what all that looks like. So in this case, to find the number of terms, it's going to be 41 minus 2, and then divided by 3, and then you always have to add this 1. So in this one, 41 minus 2 is 39, divided by 3 is 13, plus 1, that's 14. So there's 14 terms in this series. Okay? So n is 14, so we have 14 times the first term plus the last term. So a1, that's 2, a sub n, that's 41, and then divided by 2. And so this is just going to be 7 times 43, right? 14 divided by 2 gives 7. 2 plus 41 is 43. So that's 280 plus 21, so that gives 301. Okay, does that make sense? Actually, I guess you can't respond quick enough, but what should I do about this? This is a good question. Okay, I'm going to move on, and you text me if you have another question. I'm going to leave this up. Not text me. Put it in the chat if you have another question. But I'm just going to move on. I'll probably think of a solution to this later, but I can't think of one right now. Okay, anyway, for number 16, actually, I see one more thing in here. It says, how does someone join the Discord? Okay, I'm going to do a little bit of a shout out right here. There's another channel called Texas Math Mundo. You should look this up. They do like, it's run by this guy named Saul Cantu. He's a coach in Houston. Texas Math Mundo. He's a coach in Houston, and he does all this stuff for UIL. And if you look in the description of any of his videos, there will be a link for the Discord. So that's how you can join. All right, so I guess that's good. I got a confirmation from AB. Says yes, thank you. Well, you are welcome. All right, let's go to 16. Wow, we've got double-digit viewers. This is crazy. We got 10 viewers in the lobby. Oh my gosh, this is a big day. Okay, 16. We got 202 plus 317 divided by 4 has a remainder of what? So there's a long way and there's a quick way. And realistically, you could do this the long way, where you just add these and see what the remainder is when you divide by 4. But the easier way is to find the remainder of each of these separately, and then you can just add them in the end. So like, what's the remainder when 202 is divided by 4? Well, if you don't know this trick, you can actually just look at the last 2 digits and see what the remainder is when that's divided by 4. Right, so I'm looking at 02. What's the remainder when 2 is divided by 4? Well, that's just 2. And then for 317, so I'm only going to look at the 17. What's the remainder when 17 is divided by 4? Well, 16 is divisible, so I'm just going to use 1. So adding these together, you get 3. Okay, hopefully that helps. Okay, now let's look at 17. There will probably be something you can do here, but I'm just going to try simplifying. I think you're just going to have to add these. So 9 plus 6 is 15, 54 plus 18. Well, 54 plus 20 is 74, minus 2 is 72. So this doesn't look much easier, but what you can do is you can use what's called double and half, which the principle behind this is basically if you multiply one of the numbers by 2 and divide the other one by 2, in the end it's going to like balance out. And this is really helpful whenever you're multiplying by numbers ending in 5. So like 15 times 2, that's 30, and 72 divided by 2 is 36. And that comes out the same. Well, now this just boils down to, I'm going to have this 0, and now it's just a single digit times 36. So 3 times 36 gives you 108. Okay, are we all good? I'm going to screen snip this real quick. If any of you are just joining, I'm kind of just going in this order. But if any of you have questions from like the third or fourth column, I'm more than happy to jump over there. But until someone says something, I'm just gonna keep rolling. It's also my first time doing this, so we're kind of just rolling with the punches right now, seeing how it goes. Ooh, did not mean to zoom in there. Kind of just does that. Whenever I do these copy and paste things, it always, yeah, these copy and paste things, it always just zooms in for whatever reason. I'm not really sure why. All right, anyway, 16% of 6 is blank percent of 48. So I kind of imagine this as, well, of is, you can think of like the word of as like a multiplication sign. It's like 16% of 6 is the same thing as 0.16 times 6, right? And that's equal to some number times, actually I should probably use the dot if I'm using an x. 0.16 times 6 equals x times 48. And then I can just solve this for x. It might be a little bit easier to consider this as like an inverse variation sort of thing. Like going from 16 to 48, that's multiplying by 3. And so to keep it the same, I'm going from 6 to some number. I'm going to have to divide by 3 in order to keep it equivalent. So 6 divided by 3 is just 2. And you would get that same result if you did this over here. I just think it's a little bit easier to view it like an inverse relation. It says, blowing dust on my weather. I can confirm Lubbock is blowing into Abilene. You look outside right now and you can almost see Texas Tech, except it's too dusty to see anything. Okay, let's go to 19. Okay, 42 squared minus 38 squared. So if you don't have your squares memorized, this could be pretty daunting. And even if you do, this is still kind of an annoying subtraction problem. But you've probably seen this in algebra, even if you haven't made the connection, you've definitely seen this in algebra. The difference of squares, you can actually factor this to a plus b times a minus b, right? So a plus b times a minus b, and so I can actually use that to simplify this right here. So 42 plus 38 is just 80, and then a minus b, 42 minus 38, is just 4. And it says this is equal to 8 times some number. And so to find that some number, I just divide both sides by 8. And because this is an 80, that comes out really nicely. So you just get 8 equals 10 times 4, which is 40. Did I say 8 equals? I meant x equals. Yep, and so you just get 40. Daniel Ramirez, my competitor. Aiden, how do you think math results at state will look like? Well, it's definitely going to get shaken up, especially with Highland Park moving up to 6A, and well, now we've got Argyle, and there's a lot of people up and coming in math that wasn't really looking for before. Tony's been making some pretty ridiculous scores. Haven't seen a lot of what Eric's been doing, but you know, and obviously I'm just talking about 5A, because that's my classification. But you know what? I'm just gonna say that it's gonna be really good. It's gonna be really close, and well, obviously I'm working to get first, but you know, we'll see how it goes. I don't want to make any bold claims right now. I don't want to say I'm gonna win and then have this clip get pulled up over and over again. I see Texas Math Mundo, the famous Texas Math Mundo. Good stuff. All right, well, thanks. I'm doing my best. All right, number 20. 107. Oh, these ones are actually annoying. 172,023 divided by 218. Okay, what can we do here? Let's see. Estimations are definitely my weakness, and I know they're a lot of people's weakness. So 172,023 divided by 218. Well, I bet you can use some sort of fraction thing here. Okay, instead of dividing by 218, I'm actually going to divide by 222, and here's why. 222 is 2/9, right? 2/9 is 0.2 repeating, times 1,000. So if I divide by 222, it's like multiplying by 9/2 and then dividing that by 1,000. So let's see. 172,023 divided by 1,000 is just 172. And then times 9/2. Well, 172 over 2, that's 86. And then times 9, so that's 720 plus 54, so 774. Hopefully that's in the ballpark. Also, if any of you have a better idea for this, please let me know. 789 is the exact. Yeah, 749 is low. Yeah, so I guess that works. Yeah, estimations are always hard. You're just gonna have to practice those really. But okay, as long as everyone's good, we're kind of just gonna keep rolling. Okay. I also feel obligated to share a little piece of the internet that's actually pretty amazing. If you go online and you search this Bryant Heath number sense manual, a lot of you will have heard of this, but for those of you that are just starting in number sense, this is actually an incredible resource. You see UIL number sense tricks manual? Click on this. There's a whole lot of different tricks, like even suggestions on like stuff to memorize and all that kind of thing. Yeah, it's pretty remarkable. I've used this a lot. There's even a revision for like some of the more recent formulas, but that's only as of 2018, and I know he's gotten a little creative. I'll call it creative. These past couple years, so not everything you'll see on the number sense test will be on here, but okay. Here's a suggestion. It says, could you approximate 218 as 200 and 170,000 as yes. Oh no, I already got rid of it. I don't think so. I think um I I'd have to check. No, but I think that's going to be too high. Yeah, whenever you're dividing, you want to try to change the number you're dividing by as little as possible, especially because like think like if you're dividing by 3 versus dividing by 4, that has like a huge difference. Whenever you see divide, this is actually a good tip. Now that I think about it, whenever you see dividing estimations, you're always going to want to try to change the dividend, um, change this number. And if you have to change this one, change it only a little bit. Like 222, that's only changing it by 4. So like that should be fine. Okay, so that's like halfway through. Not halfway through the test, but I'm planning on cutting this off at around 6:30, just because I got homework to do. Anyway, I'm gonna start jumping around a little bit more because you guys don't need to see all of this stuff. You guys can find a lot of this stuff on your own. Like number 23, order of operations, you don't need to see me do that. Let's see. LCM, that's okay. 72 times 15, you can use double and half like before. In fact, this is the exact question from 17, just like simplified, which I thought was interesting. I wonder if that was on purpose. Maybe not, though. Number 24 is a little bit interesting. I'll pull this one up. It always zooms in. Not sure why. Anyway. So if x equals 4, then x to the 4th minus 4x squared plus 4 equals what? So obviously you could just plug this in. But it's also maybe an alternative way is to realize that this is actually a perfect square. This is actually x squared minus 2 squared. Notice like if you FOIL this out, you get x to the 4th minus 4x squared plus 4, right? And so you can use that to simplify this a little bit. So instead of having to do like 4 to the 4th is 256 minus, right? It just turns into 4 squared is 16 minus 2 is 14 squared is 196. That is a good a good skill to practice, recognizing when these are perfect squares, because that happens a lot and it really simplifies the process. Okay, that's fine. If you're just joining us, I'm kind of just working in order right now, but if you have any specific questions, I'm more than happy to skip to those. Okay, simple interest. You've probably seen this in algebra. This is just your interest equals your principal times rate times time. Base conversion. Do I want to go over this one? If you want to see me go over number 26, just send it in the chat and I'll go over it. But I think a lot of you will be familiar with that. 27 is actually a trick you can use for finding the squares from 50 to 60, which is actually pretty helpful. So I should probably show this. So anytime you have a square in the 50s, here's the trick you can do. So you say, well, how far is this number from 50? Well, in this case, it's pretty easy, right? 57 is just 7 away from 50. Squared is 49. And then you take that same number, you take the 7, and then add it to 25. So 25 plus 7 is 32. And so this answer is just 3,249. Right? So let's say you were doing like 56 squared. Right? This number is 6 away from 50. And so 6 squared is 36. And then you use that same 6 and say, well, 25 plus 6 is 31. And so that's 56 squared. Okay? That's I guess that's one way of doing that. You could have also foiled this. That's the nice thing about FOIL is that even if you don't know the trick, a lot of times you can kind of get away with it, but obviously you want to be doing it the quick way. All right, let's see what else we have. Number 28 for 101. That requires you to know like formula for multiplying by 101. But I won't. Actually, maybe I'll do this one. This is kind of just working backwards from multiplying by 101. So I'll show how to do that, and then maybe if I do that, it'll be a little more obvious how this one works. So let's say you're doing like, maybe you're doing like 121 times 101, right? The first thing you do, you look at the last two digits, and you just write those. So that's going to be your tens and ones place, right? And then the next thing you do is you add your hundreds and your ones place, right? 1 plus 1 gives you 2. And then you just write hundreds and tens. So this just comes out to 12221, right? And so you can use that same kind of pattern looking here, right? 13,332 divided by 101. Well, we know whenever we multiply by 101, the first thing we do is just write the last two digits. And so we can already tell that our last two digits are 32, right? And then over here, the last thing we do is just write our hundreds and tens digit, and we get 13. And so we see the 3 is here already, so we can tell this is just going to be 132. And then checking it even further, right, this middle digit here is just the sum of our hundreds and ones. So 1 plus 2 gives you 3. So that requires a little bit of information from that, but there's also, you can also find that in this big manual. Multiplying by 101's trick. Are there any dividing ones? Oh, here we go. Oh yeah, here we go. There's some dividing ones. So you can use those to practice. Okay, let's keep going. 29, you can just factor. 30, just no perfect squares. 31, fraction FOIL. I might go over fraction FOIL. Trying to speed up this process a little bit so that we can start getting to the end of the test. Okay. 8 1/4 times 4 3/4. Okay. So, fraction FOIL. So, this requires you to know a little bit about like just regular FOIL, but I'm assuming that all of you have taken algebra or have just learned it if you're on this stream, if you're doing UIL. So, first thing you do is you look at the fraction parts and you just multiply them together, right? Easiest part. So 1/4 times 3/4, that's just 3/16, right? And then, so that's the L part. You're kind of using the fraction as like the ones digit almost. And then the outside inside, so that'll just be 1/4 times 4, and then 8 times 3/4. So a fourth times 4 is 1, 8 times 3/4 is 6. So together that's 7. You are going to have to carry that 7. So you could just carry it on your fingers, or if you got the mental power, you can just carry it in your head, either one. And then for the f, you just multiply the whole number part. So 8 times 4 is 32. So to get this part right here, it's just going to be 32 plus 7, which is 39. Sweet. Okay. If I'm going too fast, or I say something that doesn't make sense, or I make a mistake, please let me know. I don't want to confuse anybody. And if you think I said something wrong, there's a good chance that it was wrong. But don't be scared to call me out on that. I make mistakes all the time. Okay. 24 has how many positive integral divisors? Okay. This one's interesting. Oh, look, number 33 is another fraction FOIL. I guess that's nice. But then again, if you don't know it, you have to skip 2 questions, so it could go either way, I guess. Okay, 24 has how many positive integral divisors? Okay, this one, you got to know how to take a prime factorization. So I'm going to kind of assume that you already know how to do that and know what that is. But the prime factorization of 24 is just 2 cubed times 3. And so if you want to find the number of positive integral divisors, I'll call this times 3 to the first. You take each of these exponents, so 3 and 1, you add 1 to each of them, so you get 4 and 2, and then you just multiply them. So 24 has 8 positive integral divisors. It's a lot faster than just counting them, at least in my opinion. So that's that. Trying to go quickly so we can get to the end. Yeah, 33 is just another fraction FOIL. 34, I'm going to assume that you guys can factor, because you would have learned that in algebra. 35, 22 dogs bark at cats, 17 bark at birds, and 9 bark at both. Okay. This is a little bit of an interesting one. I don't know if I've seen this on number sense very frequently. This might be one of the only tests I've seen this on. That's okay, though. Yeah, later on I'll figure out how to set up like a voice chat. I might even have like guests on here. It'd be pretty cool if I got like Nicholas Ellison in on this. That could be pretty fun. But, that's for another day. Alright, so 22 dogs bark at cats, 17 bark at birds, and 9 bark at both. How many dogs were there? Okay. Let's see. Okay. So you guys have done like Venn diagrams before, right? So basically, here are the ones that bark at cats. Here are the ones that bark at birds. And I know the circles are bad. Dude, drawing circles on this little pen pad that I have is kind of a struggle. So, yeah, it's kind of a struggle. Anyway, so 22 dogs bark at cats. And so basically in this full circle here, there's 22 in there. So in this part, plus the intersection part, there's 22 in there. 17 bark at birds. Oof, that is really rough, but hopefully you get the idea. So 17 bark at birds. So this entire thing is 17, right? And then 9 bark at both. So just in this little section, that's 9. So we want to find out how many total there are. Well, let's start off, we're going to overcount a little bit, but let's just say that the total number of dogs is just 22 plus 7. Well, what's the obvious problem with that? Well, it's that we've counted the ones that bark at both. We've counted them two times, and we only want to count them one time, right? We counted them once whenever we found out how many bark at cats. We counted them again. We counted how many of them bark at birds, right? And so to find the number of dogs, you just take this overcounted number, and then subtract out this 9 because we counted this twice. So this is just going to be 20. Wait, is that right? 22 plus... I feel like I made a mistake. Nope, 22 plus 7 is not 29. Wait, what? Oh, it's because it's 17. I can't... It's because this 1 was right here. Yeah, 22 plus 17 is 39. There you go. And then 39 minus 9 is 30. See, I make mistakes. Usually it's not because I can't read my own handwriting, but you know, it comes and goes. Okay, that's that. If you want to learn more about this is actually called, it's kind of simplified as PI. It's the principle of inclusion and exclusion. Principle of inclusion and exclusion. There's tons of stuff on like the Art of Problem Solving website about this, and it's actually pretty interesting. And it comes up on math all the time. I haven't seen it on number sense as much, but it comes up on math all the time, so it's definitely worth looking at. Okay, let's keep going. Just out of curiosity, so reading this chat, there's not a whole lot of activity going on. I want to know how many of you guys are interested in the fourth column. So just send a quick text if you're interested in the fourth column, because I'm kind of going fast so that I can get there, but if no one is interested in getting there, then I can slow down. Yeah, because I don't really know what skill level you guys are at. I don't know if I've already gone too far, and you want me to just do the second column really slowly. Like I said, this is kind of a first time thing. Okay, let's, in the meantime, let's look at 36. So, remember up here, whenever we tried to find this remainder, when it's divided by 4, well, we can do a very similar thing here. Just find the remainder when each of these things are divided by 4, and then just do the operations, right? So 14 divided by 4, that has a remainder of 2. 10 divided by 4 has a remainder of 2. 73 divided by 4 has a remainder of 1, right? Because 72 is a multiple of 4. So 2 times 2 is 4, plus 1 gives you 5. And 5 divided by 4 is a remainder of 1. You say, I don't mind. You don't mind going to the fourth column, or you don't mind me going faster. Anyway, that's going to take some time for you to hear, so I'm just going to keep going. The other way you could have done this is you could have said that, well, both 14 and 10 are even, right? They're both multiples of 2. And so multiplying two multiples of 2 together, of course, that's going to be divisible by 4. And so you could have just skipped to the 73 part and said 73 divided by 4 has a remainder of 1. Okay. That's a pretty common thing to see on number sense. And once again, in that little packet, I say little, it's like 200 pages. 100, yeah, it's like 200 pages. There's questions about that as well. So you can definitely go and practice. Okay. Let's see. Let's keep going. How many integers between 3 and 33 are relatively prime? Ooh, this is a good one, actually. This is a good one to go over. So, if you're not familiar, relatively prime just means you don't have any common factors besides 1 in itself. Sorry, you don't have any common factors besides 1. Sorry, I misspoke there. So, for example, like 15 is obviously not a prime number, right? But 15 and 4 are relatively prime. Because they share no common factors besides 1. So that's what it means to be relatively prime. And no common factors besides 1. And this actually introduces something interesting, and it's that 1 is actually not relatively prime to, it's not relatively prime to anything. Because, like, let's say you had, like, 4 and 1. Actually, no, they are relatively prime. I misspoke. Right, so 4 and 1, they don't share any common factors besides 1. Well, because 1 is the only factor of 1. So these are still going to be relatively prime. So the formula you can use for this is you just have to know what the factors of 33 are. If we want to find what numbers are relatively prime to 33, we just need to know the prime factors. So 33 can be broken into, 3 and 11? You don't even have to know, like, the exponents or anything. You just have to know the prime factors. So to do this, you're going to multiply by 2/3 and then by 10/11. So you see, the numerator is always just one less than the denominator, and the denominator is just the different prime factors. So 33 times 2/3 is 22, times 10 over 11 is just 20. And that's for finding the number of relatively prime numbers less than the number. But we have this extra stipulation, right? So since it's between 3 and 33, we can't include 1, 2, or 3. We can't include those ones. And so we're going to have to subtract out the ones that are also relatively prime. So 1, we established that's going to be relatively prime. 2, that's also relatively prime, right? Because 33 does not share any common factors with 2. 3 will not be relatively prime because they both share that factor. So you just subtract out those 2, and you end up with 18. All right, is everyone doing okay? Am I moving too fast? Okay. Once again, is there anything you guys want me to go over in particular, or are you guys kind of just good with me going in any which way? All right. Anyway, okay, let's look at 38 then. This is a pretty simple pattern compared to what they ask sometimes, honestly. This is just the prime numbers, right? And I guess you're just gonna have to have your prime numbers memorized. But anyway, the next prime number in this sequence, like P is 13, R is 23, and so together that's just 36. I won't go too much more into that. Let's see, 6 squared divided by, okay, so that's just laws of exponents. Can I cover number 40? Yes, I was just getting to that. Let's see if we can come up with a good way to do number 40. You know, I've been saying this for a while, and I really think that Microsoft Whiteboard should have a button where I can just clear everything. And I really hope there's not, or else I'm about to hear it. Yes, you say 1 is relatively prime to every number. Yes, I think I just misspoke. I was thinking about it backwards, I think. But yeah, you're right. 1 is relatively prime to every number. Yes, it's kind of like how 1 is neither prime nor composite because it doesn't really fit either definition, and so yeah, it's the same kind of thing. All right, so 142 times 39 times 138. So first thing that jumps to my mind is just doing 140 times 140, right, for these two. That's the first thing that jumps to my mind. And then I guess rounding this to 40, right? Okay, so 14 times 14 is 196 times 4 would be 784. And then you just got 3 extra zeros. I think that's in the range. Let me just double check. You could have also done, 1 second, let me just double check that this is in the range. Ooh, it's a little close, actually. Yeah, actually, no, that's fine. The upper limit on that is like 800,000. If you didn't want to do 196 times 4 in your head, you could have like taken the. Let me show this a little bit clearer. Like split the 40 into 4 and 10, and then take this 4, apply it to each of the 140s. So now it's 280 times 280 times 10. And then if you have 28 squared memorized, it's just 28 times 28 is 784 with your 2 extra zeros. Yeah, so you could have done that. If there's a better way that you guys know of, I'm all ears, but actually, there might be an easier way, but I'm going to respond to this real quick. It says, so what if you had more than one of the same prime factor for relatively prime? Not 100% sure what you mean by that. Are you saying that, like, Wait. Can you elaborate just a little bit? Are you saying like are 21 and 21 relatively prime sort of thing? So what if you had more than one of the same prime factor? Oh, I think I see what you're saying. Maybe you'll correct me. But like maybe asking like if 60 and 15 are relatively prime, right? So like 60's prime factors are 2, 3, and 5. 15's prime factors are 3 and 5. And so you're saying like, well, they share 3 and 5. Does that still count as not relatively prime? Yeah, these are not relatively prime. Hopefully that's what you're saying. Okay. Anyway, I guess the other way you could do this, you could say, and I literally just thought of this, but what you could say is, well, 1/7 is like 0.142, and so you could replace 142 with like 1/7 times 1,000, right? And then times 39 times 138, maybe round 138 to 140, and then 140 times 1/7 simplifies to 20, so it'll be 20 times 39 times 1,000, which would just be 780,000. Yeah, I guess that works. That's interesting. It's really just up to you which one you decide to use. Yeah, it's entirely preference. On estimations, there really isn't one better way or the other. So hopefully that helped. Okay, let's see. We only have a few minutes left. So let's see. What's gonna be the lucky question that gets picked? Anyone have any suggestions? I am I am more than open for suggestions. Okay, I think I'm just gonna pick one. Okay, let's see. How about number 49? Oh, actually, someone just sent 49. This is a really good one. Okay, there are some variations of this that I'm still figuring out, but I have a lot of them figured out. And so let's hope that this is one of them that applies. Okay, 49. Let 3 times 3 over m times n and 1/3 equal 12, where m and n are natural numbers. Find m times n. So really, if anyone has a better way of doing this that requires a little bit less guesswork, then I would be very open to that. But for now, you can see, well, let's say that n was 4, right? So 3 times 4 is already going to give you 12. And so anything like on top of that is going to make it greater than 12. So I'm going to kind of just guess right now that n equals 3, right? Then making this an improper fraction, you get, so n and 1/3, let me, let me show this a little bit better. N and 1/3 would turn to 3 and 1/3, which is just 10/3, right? And so if you think about what 3 times 3 over m would be improper, right? That would be 3m plus 3 over m, and then that's multiplied by 10/3. Well, in order for this to come out evenly, right, we're going to have stuff cancel. And so m is basically just going to have to be, it's going to have to be a number that will cancel out with 10. And in this case, well, the thing with this is, and yeah, this is kind of the thing. So m could be 10, right? But at the same time, like if you're using this logic, m could be 20. It could literally be any multiple of 10. That's why I'm asking if there's a better way. But this is the best way that I've figured out so far. Yeah, you kind of just say, well, this is going to have to cancel. So I'm going to say that m equals 10. And then 10 times 3, right? mn. 10 times 3 gives you 30. So it does require a little bit of guesswork. I'm trying to figure out a more consistent way of doing it, especially since sometimes this n right here is actually, maybe it's like 2 less, right? So sometimes instead of being 3, it'll be 2. Why not factor? Let's see, what do you mean by that? This might be a better way. I'm definitely open to hearing this. Are you saying like you can do a fraction FOIL sort of thing? I mean, I guess I can try that. There might be a trick that kind of just, there might be some things that just cancel and it comes out nice. So let's see, 3n plus 3n over m plus 3 times 1/3, that's just 1, plus 3 over 3m. That's not very nice, but we're gonna push through. I'll put those under a common fraction, right? 3n plus 3 over 3m, converting into improper fractions and solving. Yeah, I've thought of that. It's just pretty difficult because there's technically an infinite number of solutions, right? And so it's really hard to. You would have to like whichever one you chose, you would have to double check it. And on number sense, obviously that's not ideal. Okay. Um. Maybe. Wait. Actually, this cancels. Wait. Not over 3m. Just over m. Maybe there's something to the fact that like these are the same, or is that just because this has a numerator of 1? And this equals 12, right? So m has to be a divisor of 3n plus 1. Right? Actually, which is what we figured out anyway. Actually, n is limited, right? Because n has to be less than 4. Okay, so okay, hypothetically, okay, let's just try this. For whenever this simplifies, right? Okay, let's say n equals 1. Then 3n plus 1 would be 4, and then over m would have to simplify. For n equals 2, it would be 7 over m would have to simplify. For n equals 3, it would be 10 over m has to simplify. Hmm. I might just be grasping at this point. Yeah, I've worked a lot on this. And I'm just trying to find a more consistent way, but this is the best way I've come up with so far. Um, yeah, but if I find a better way, I'll definitely tell you guys. I might even ask a handful of people what they think. Um, but this comes to the end of our hour, and in fact, we actually went a little bit over. But hopefully, you guys learned a good amount from this. Um, I'm gonna try to do this at least once a week, especially until UIL state. It might slow down a little bit because I am graduating, and so I'm gonna be pretty busy in May, especially since state is like so late this year. Oh yeah, by the way, if you didn't know, UIL State is like May 17th and 18th. It's like during the week. It's like a Wednesday, Thursday, or like a Tuesday, Wednesday. Apparently people at UT, apparently the UT people forgot to, not the UIL people forgot to book the venue uh, at UT for the weekend, and it got like booked up. So that's interesting, but at least it doesn't conflict with AP tests this year. It says, will you be going over questions 40 through 80 later? Uh, Probably. Um, if there's demand for it. If you're on the the Discord, which if you don't know, go to Texas Math Mundo. It's a little bit of a shout out here, kind of second one of the stream. Yeah, Texas Math Mundo, and go into any of his descriptions, and there will be I misspelled description. Go to any of the descriptions, and you'll see the Discord. There'll just be a link for it. But yeah, you can always just text me on there if and if there's enough demand for it, I'll definitely make another one. But if there's not and you just have questions, just text me. Um, my name's Aiden, by the way. You guys didn't know. I'm from Wiley. I might even be seeing some of you, like at Region and State. I don't know if anyone here is at Region 1, but we'll see. Yeah, I'm from 5A. Man, 5A sucks in math. Or not sucks. It sucks being a competitor in 5A math. Everyone's so good. Anyway, yeah, so that kind of wraps it up. I hope you guys enjoyed. If you haven't yet, subscribe. That's kind of just a thing that I guess I'm supposed to say at the end of a stream. I haven't really done one of these before. I'm not really sure how to end this, but um, you're in Region 1. Are you in 5A? Actually, I might recognize his name. Oh, 6A. Okay, 6A. Okay, I don't really keep up with a lot of 6A schools. I kind of just know Clements and Elkins because those guys are always battling it out. But okay, well, it should be interesting. If you guys have any meets coming up, TMSCA State's coming up pretty soon, so you guys can definitely, yeah, TMSCA State's coming up soon, so you guys should definitely show up to that. Ask your coaches about it. Um, but yeah, well, I guess we're done. So I'll see you at the next one. See ya. I said that, and then I realized that I don't know how to end this stream. Oh, it's right here. All right, bye bye.